Hello and welcome everyone to our webinar. The topic today is the investigation of district heating and cooling systems using CO2 as heat transfer medium. For those who don't know me, my name is Robert Pratter from Forward Energy Research, and I will guide you through this webinar for the next, let's see, 1.5 to 2 hours. Just one moment, here it is. The webinar is part of our CO2inloop project, which is funded as within the AeroNet Geothermica initiative. And as you can see in the project team, it's a Danish-Austrian cooperation. We have a good mix in the project team of different organizations from research, like our colleagues from the Technical University of Denmark or us from Forward Energy Research, from engineering offices and other SMEs like Pratter and Scherling, Prozess Optimal, Aros Technik, and also district heating suppliers like Aalborg Forsyning. We've started with the project already in 2022 and will end the project by the end of October this year. So as you can see, we are almost at the end of the project, but this also has the advantage that we have a lot of interesting results available, which we would like to present and discuss with you today. Talking about the agenda, after a short introduction, I will hand over first to my colleague Verena Kerschenbauer from Pratter and Scherling. She will present to you our results of the techno-economic assessments of the CO2 networks and also compare them with different reference scenarios like conventional water-based district heating and cooling networks. After that, my colleague Hans-Georg Hirt from Prozess Optimal will talk about the CO2 network simulation, control strategies and safety measures. And then the next two presentations, they will give us an insight more from the practical side. First, Bertil Möller-Jensen from Werdo, and after that, Mark Piper-Pertison from Aalborg Forsyning will present us their view on the district cooling and district heating in Werdo and in Aalborg Forsyning, the development and also how the CO2inloop approach could help in this regards. And last but not least, Mai Samsadi from the Technical University of Denmark will present his results on operational optimization strategies to enhance the performance of district energy systems using CO2. So let's call it the first part, which is mostly focusing on presentations. And after that, we would like to go in a discussion with you, being a bit more interactive and discuss and hear from you what you think about the approach of CO2 networks. Please mute your microphone when you're not speaking. If you have any questions, and I hope you do, please use either the chat or the raise hand feature. We have reserved some time for 1 or 2 questions after each presentation. If there are more questions, we can also use the second part of the webinar to discuss them further. Moreover, I would like to inform you that the webinar will be recorded and that the presentations will also be made public available afterwards. We will share the link with you, of course. The discussion part will only be recorded for internal use. Then let me say a few words about the concept of CO2 networks in general. So when we talk about CO2 networks, we mean district heating and cooling networks, which uses CO2 as heat transfer medium within the pipes instead of water. And the system is designed in such a way that it uses the phase transition, meaning that we have one liquid and one vapor line. Temperatures are around 10 to 15 degrees. This depends a bit on if the network is mostly used for cooling or for heating operation, and can of course also be varied during the year. The pressure, or this leads to a pressure of around 50 bars. The advantages of the system are, on the one hand, that we can use it simultaneously for heating and cooling. So we have just one network you can supply at the same time heating and cooling. For the heating operation, usually we will, of course, need heat pumps to increase the temperature level to the level needed. Cooling can either be done directly or also with heat pumps. This depends a bit on which temperature level you need for cooling. We can also efficiently use and integrate low temperature energy sources like lakes and rivers. And another advantages, and this is especially important in comparison to conventional water-based networks, also to the low temperature fifth generation ones, is that we can use smaller pipe diameters and we can use unisolated pipes. So this means that the CO2 network is especially suitable for dense urban areas where you already have a lot of pipes and other equipment in the ground. The challenges we're facing in the project are the complexity and also the high pressure. So for the complexity, we have the phase transition. So we have one liquid and one vapor line, and we have to ensure that we don't have any unwanted phase changes. So for that, we have also designed the so-called phase change prevention system. My colleague Hans-Georg Hirt will present this later on in his presentation in detail. So you have considered these aspects. You have to probably design the system and use a proper control strategy. But if you do that, it's at the end, it's not that complex anymore. And also regarding the high pressures, 50 bar, that's of course are high pressures, but these are also pressure levels which are already used in some of the gas pipe systems. So there are components available which are suitable for these pressure levels. What have we done in the project? At the beginning of the project, we started with the investigation of the technical, economic, ecological, and legal framework conditions. So we looked into that detail. What components do we need? What is already available on the market? Which components are special for the CO2 networks? Which requirements do we have? Which costs comes with that? One particular component which is very important, of course, are the pipes. So we saw that if we're going for steel pipes, it's not that hard to find suitable solutions. If we want to have flexible composite pipes, which have their advantages, of course, there are only a few options on the market at the moment, but still there already are. And yeah, we also did a market analysis. So we tried to estimate the potential of the CO2 networks, mostly based on the potential of district cooling networks, since we saw already at the beginning that those use cases which includes cooling are those which sounds the most promising ones. Then as a next step, we defined different operation and business models. So here we really had a huge playground, different things we can consider and combine. So for example, we had to define which energy we would like to supply. Are we talking about only cooling? Are we talking about heating and cooling? If it's both, do we want to supply it at the same time, or is it mostly heating during winter time, cooling during summertime? Then we can look into which energy sources we would like to use, lakes or rivers, for example, but we also investigated scenarios where we connected the system to an existing district heating network. So here we are at point 4. It also makes a difference if we plan the CO2 network at an area where we don't have any pipe-based solution yet, or if we do it somewhere close to another system, or perhaps in an area where the consumers already supplied by a conventional district heating network, and we only want to do the cooling with the CO2 network. So all of those things can be considered. If a district heating network is close by, you can also use the synergies, for example, use it as a heat source, and perhaps even consider feeding in the heat during the cooling operation in the conventional district heating grid if there is use of that during that time, so mostly summer, of course. And yes, the last aspect, we also looked at the system borders. Usually we need heat pumps at the consumer stations, and the heat pumps needs electricity. So we also thought about, are there any options, solutions available that the operator of the CO2 network also supplies the consumers not only with heat and cold, but also with electricity. Here, energy communities are quite interesting. So we could think about scenarios where the operator installs a huger PV system, for example, at the central station, which not only supplies the central pumps and heat pumps, but also has some surplus, which can be shared via an energy community with the consumers to at least cover a share of the electricity needed. This can be especially interesting if the system is installed in areas like cities, for example, where the customers are not able to invest in their own photovoltaic systems. Yeah, but based on all these options, we try to define several operational business models, and to investigate them further, as next step, we have modeled the system based on a smaller network with a few consumers in Aspen HYSYS and MATLAB. We have used the simulation to design the main components, also dimension them, and for the identification of a suitable control strategy. And then we also looked into supply safety and general safety as well. And yeah, as a last step, or kind of last step, we carried out a techno-economic evaluation of all these use cases, combined them with reference scenarios, so conventional water-based district heating and cooling networks, and tried to find out which configurations are the most promising ones, what are suitable use cases, so which requirements do we need, and then, and that's what we are currently doing, we try to derive recommendations and guidelines, and also think about the next steps. So what is needed to bring the concept of CO2 networks another step closer to the praxis. Yeah, this was of course not a linear progress. We did a lot of iterations, defined new operation models, fine-tuned them, adjusted the components, adjusted the control strategy. But at the end, and that's just maybe a little spoiler to the presentations which come next, and where you will hear about all these things a bit more in detail. We found out several use cases which are looking quite promising, also in comparison to the reference scenarios, and also considering the early stage of the CO2 network approach. So we definitely think that it's worth to investigate this technology further, and that's also what we're aiming to do.